Hello, everyone. Today we are going to talk about our project, Emotion Recognition in Artworks, Analyzing Visual Emotions with CNNs and WikiR data. This is our outline for our presentation. First, we'll give the intro and present the data, and then we will show our techniques applied in our project, and then we show our results and discuss our results for future expectation. A little bit background information. Like there is a surge recent years for requirements for image analysis utilized in environmental design and business. And there's also increasing in development for the AI-based chatbot and CNN for image classification. And our goal for this project is to develop a chatbot that performs image analysis by leveraging output from a CNN model and integrating response use LLM. The novelty for our project includes there's the integration of CNN and large language model for image-driven conversation, and there will be a web page for the chatbot, so the user can have better experience for the interact with our chatbot. And then the data we use is called the WikiR's emotions dataset. The dataset is from a psychological study by Saif and Muhammad and other researchers in this to complete this dataset. And this includes about 20 annotators were shown over 4,000 artworks and asked to write down the emotions and the artworks invoked. The images include the image, and we will put it from the URLs provided by the images. And here is the distribution of the artworks by in different emotional classes. And then we do the data processing. First, we pull the dataset from the different websites, and then we do the data frame construction, and we build different data frame for analysis, such as the URL data frame and emotions data frame and top emotion data frame by various threshold for the multi-classes label. And the main data frame that we use is tri-classes classification model, and which separate the emotions to about 3 classes like positive, mixed, and negative, so that the model will train by the three classes labels. For the techniques part, and we apply the Google Cloud platform for our model training. And in this platform, and we use a bucket storage, and which is a large image data data frame and model storage. And for the VM instance, we use NVIDIA T4 and with about 15G storage. And this is also good for the API integration, and it is good to create, deploy, and manage RESTful API to connect to the chatbot backend with app or other service. For the convolutional neural network part, we mainly did about three classes classification, and the first one is multi-class, and we did the baseline, and we also do the another architecture with a MobileNet V2 as our basic model, and then we add the transfer learning, data augmentation, and dropout and regularization to see there is an improvement for the model training, and then we do the binary class, which is separate the emotions to positive and negative. And for this, we also do the baseline, and we also apply the MobileNet as a base and add on the transfer learning and data augmentation, plus with early stopping. For the trait classes, which is the emotion model that we use for the combined with a large language model, and we do the baseline, and then we also do the mobile net way too, and plus with transfer learning, data augmentation, mobile net, and there is a significant improvement on the accuracy, and this is our structure for the model for CNNs. For the result, and there is a for the multi classes, it has highest accuracy about 30%. For both binary and tri classes, which has a much higher accuracy, and for the binary one, which has about 55%, and for the tri classes one have about 30 accuracy, which is good for you. So we choose use tri classes one. And for large language model, and we apply the Llama 2, which found by the Meta techniques, and it is a good language model because it is a collection of pre-trained and fine-tuned generative text models, and its size ranging from 7 billion to 70 billion parameters. And for the fine-tune part, we use the Go emotions dataset by Google Research, and allows the model to learn nuanced emotions, expressions effectively, and make it better suited for emotion-driven application like chatbot. And Hugging Face Transformers library and the Llama 2 checkpoint, and we also incorporate the LoRa for our fine-tune process.
Let me explain how this chatbot works and the technical details behind it. At the core of this system is a Python class called Art Emotion Chatbot. This class integrates two powerful AI models, a convolutional neural network and the Llama 2 conversational model. This CNN is responsible for analyzing uploaded images, extracting visual features, and predicting one of the three emotion labels, positive, negative, or mixed. The Llama 2 model, on the other hand, generates human-like responses, adapting its dialogue based on the detected emotions and the user's input. When a user uploads an image, it's resized to 180 by 180 pixels and normalized to meet the CNN's input requirements. The CNN implemented with TensorFlow processes the image to extract features and outputs on emotion models, on emotion label, along with a confidence score. This emotion label, along with the user's text input, is passed to the Llama 2 conversational pipeline, which was built using Hugging Face Transformer library. The Llama 2 model uses this combined information to generate dynamic, context-aware responses that integrates the emotion analysis with conversation flow. Next slide. Here is chatbot demonstration. The user uploads an image and types a message. The system processes the image and predicts its emotional tone. For example, in this case, the system detects a positive emotion with a confidence score. This emotion label is passed to the Llama 2 conversational model, which generates a response tailored to the detected emotion and the user's input. For instance, when the user clarifies it's an art painting, actually, the chatbot adjusts its response dynamically, emphasizing the emotional impact of this artwork. From a technical perspective, the chatbot is deployed using Gradio, a framework that provides a user-friendly and interactive interface. Gradio allows users to upload images, enter text, and receive real-time predictions and responses. behind the scenes, it integrates CNN for image analysis with the Llama 2 model for conversational AI, ensuring smooth operation. This chatbot offers several key features. First, it provides seamless integration between visual analysis and conversational AI, making it engaging. Second, it delivers real-time feedback, instantly processing images and generating responses without delays. Finally, it integrates context awareness, enabling the Llama 2 model to understand conversational flow and produce replies that feel natural and relevant. In the next slide, it's our interactive web page deployment. We also developed a user-friendly web page where users can upload artwork images to receive instant emotion predictions. This system dynamically displays results, making art exploration intuitive and engaging. The backend built with Flask handles image pre-processing, runs the model, manages requests, and includes errors handling for invalid inputs. The in-front end, designed with HTML, CSS, and JavaScript, ensures a responsive layout and real-time updates without page reloads, providing a seamless user experience. In sum, our project successfully achieved reliable results in image classification throughout the use of CNNs, employing various model architectures to enhance performance. The integration of emotion detection models with a fine-tuned Llama 2 was a key component in building an advanced chatbot. This chatbot is deployed on a web-based interface, enabling seamless image analysis and interactive communication, which provides a good feedback based on input images and the response. In the future, we want to enhance the accuracy of emotion model and the reliability for more comprehensive image analysis. Additionally, there could be an improvement for the chatbot, enabling users to not only analyze images, but also request the images generated based on the specific emotions. To further optimize the chatbot's performance, it's also possible to explore and implement advanced fine-tune techniques for the LLM, ensuring higher quality and more personalized outputs. Thank you.